5.3 multiplying polynomials special products. We're using MA 912 AR 1.3. We're going to find products with monomial multipliers. We're going to multiply binomials using the distributive property and box method. And we're going to identify and use special binomial products. So in example 1, it says 3x squared parentheses 5x minus x cubed plus 2. First thing we need to do, first put the bubble parentheses in descending order. So I'm going to rewrite it to say 3x squared times negative x cubed should come first, then the 5x, then the 2. So I am going to use the box method. So you can use distributive, but the box method makes a little bit more sense. So we have 3x squared, and we're multiplying to negative x cubed, positive 5x, and positive 2. We are multiplying we're multiplying them together. So think of Punnett square from biology days. 3 times my negative 1 is a negative 3. 2x's plus 3 more, there are 5 in total. 3 times my positive 5, that's 15, that's positive. 2x's plus the 1 more, you have 3 in total. 3 times my 2, that's positive 6. 2x's here, none here, I still have 2x's. So your final answer is negative 3x to the 5th plus 15x to the 3rd plus 6x squared. On example 2, it says the parentheses binomial 2x plus 3 times the binomial x minus 2. Again, you can use the box method. So you basically drew a 3 by 3 grid, like you're playing tic-tac-toe. You're going to put 2x and a positive 3 because that is what that binomial is. The second binomial says x minus 2, so I'm going to write an x and a negative 2. I'm going to put a multiplication dot in that corner, saying that I need to multiply them. So we see, and we're filling in these boxes right here. So 2x times x, 2x squared. 2x times negative 2, negative 4x. 3 times the 1, 3x. 3 times the negative 2, negative 6. So then what's in the bottom 4 is your answer combining like terms. So we see 2x squared, negative 4x, positive 3x, negative 6. The two middle terms are the ones that combine together. So you get 2x squared, negative x, minus x. Because remember, you're short $4 but found 3, so you're still short 1. And that would be the result of the multiplication. In example 6, they want you to simplify the expression and write the result in standard form. Standard form, remember, is in decreasing power. So first thing we see the binomial 3x squared minus 2 times the binomial 4x plus 7 minus 4x in a bubble power of 2 squared. So first thing we're going to do, we have a box method and then exponential power. So we are going to do the box on the first part. So I'm going to write 3x squared negative 2. We have 4x positive 7 minus, and it says 4, so you're seeing 4x times 4x. So we're multiplying 4 times the 3, 3 times the 4, there's your 12, 2 x's and 1 more, x cubed. 3 times the 7, there's your positive 21 with an x squared. Negative 2 times 4, that's negative 8 with an x. Negative 2 times 7, that is negative 14. So now we see 12x cubed plus 21x squared minus 8x minus 14 minus sign. 4x times 4x, that is 16x squared. So on the first section, none of them combine because we have power of 3, power of 2, power of 1 plain number. But now I'm subtracting 16x squared. So the 21 and the negative 16 are the only two combining. So we end up with 12x cubed, had 21 but spent 16, I have 5x squared, negative 8x, negative 14. For final answer. This one's going to encompass examples 7 through 9. They're all the same topic. It says write the polynomials in standard form and then find the product of x plus 3x squared minus 4 and 5 plus 3x minus x squared. So remember, first you need to rewrite them in standard form. So the first parentheses, it should be 3x squared minus, plus an x actually, minus a 4. But then remember it says product means multiply, and I'm multiplying it by the next parentheses, so it's now going to be negative x squared, positive 3x, positive 5. So you're taking the two polynomials they gave you, write it in standard form, and it says they want the product of the two. So this is going to be a very big box. So we see 3x squared, positive x, negative 4. We have negative x squared, positive 3x, positive 5. The reason for the box method is so that in case you had to do polynomial multiplication here, you're not doing distributive property 9 times. You can just do it in the box and it gives you your answer faster. So now I did my multiplication dot. I see 3 times my negative 1, that means negative 3. 2 x's with 2 more, that's x to the 4th power. 3 times negative 1, 3 times my positive 3, there's my positive 9. 2 x's with 1 x, and that's 3 of them in total. 3 times your 5, that's 15. 2 x's, no x's, you are still x squared. Then you go down on the line. Positive 1 times negative 1, it's negative 1. X with 2 of them, 3 of them. Positive 1 times positive 3, that's positive 3. X of x, x squared. Positive 1 times 5, positive 5 with an x. You go down another line. Negative 4 times negative 1, positive 4. No x's, but you have 2 on the top one. X squared slides down. Negative 4 times 3, negative 12. No x's, but 1x, x comes down. Negative 4 times 5 is negative 20. No x's, you're just negative 20. Next thing you want to notice is diagonally, you have like terms. These two have the same attachments. These 3 have the same attachments. These 2 have the same attachments. So I'm going to rewrite it as one big line. So we see negative 3x to the 4th, positive 9x cubed, positive 15x squared. Then the next line, it says negative x cubed. I'm going to line it up, negative x cubed, positive 3x squared, positive 5x. I went over a line. You drop down a line. It says positive 4x squared. I'm going to line it up with where the x squareds are. Positive 4x squared, negative 12x, negative 20. And now you are going to add down. So negative 20 is the last digit by itself. $5, that's positive, and you spent 12, you're short 7x. 15 plus 3 is 18. 18 plus 4 is positive 22 x squared. 9, take away 1, you still have 8x cubed. And then negative 3x to the 4th slides down. And then you have your finished product. Okay, special products. These are terms that you learned back in Algebra 1 at one time or other. Difference of squares. If you see, it's in the form of a plus b times a minus b, the binomials, which results in a squared minus b squared. Sum of perfect squares. It's when you see a plus b times a plus b, which means the same bubbles are repeated. The formula for that is a squared plus 2ab plus b squared. If you see difference of perfect squares, that's when you see a minus b times another a minus b. And again, notice that perfect sum and difference are the same, they only differ in sign. So it goes a squared minus 2ab plus b squared when it's a difference. Sum of cubes and difference of cubes. A power 3 plus b cubed, a power 3 minus b cubed. Now let's look at our expansions. It says a plus b times a squared minus ab plus b squared. When you look at the difference, instead of a plus b, we write a minus b. We wrote a squared minus ab plus b squared when it was sum. For difference, you're going to write a squared plus ab plus b squared. It's So basically what happens is we want to everything cancels out and you're only left with two pieces when it's sum and difference of cubes. So when we look at the examples, we're going to apply those rules. The first one says 5x minus 6 times 5x plus 6. This is difference of squares. So easiest way is identify what A and B is. A is a 5x, B is 6. And the formula says it's A squared minus B squared. So I'm going to write 5x in a bubble squared, minus sign, and then 6 in a bubble squared. So 5 squared, that is 25, x squared minus 6 squared, 36, and you're finished. On B, it says parentheses 3x plus 7, and it's repeated twice. This is your sum of perfect squares. So the A is 3x, the B is 7. And the formula said it's A squared plus 2AB plus B squared. So the A was 3x, I'm putting it in parentheses, power of 2, plus 2 times the A was 3x, the B was a 7, plus the B, which was 7, squared. So 3x times another 3x, that's 9x squared, plus 2 times 3 is 6, 6 times 7 is 42 with an x, plus 7 squared, 49, and you're finished. On C, it says parentheses 4x minus 9 close squared. This is your difference of perfect squares. So the A is 4x, the B is 9. You don't take the signs into account. So the formula says it is A squared minus 2AB plus B squared. So A was 4x in the bubble squared, minus sign 2 times A, which is 4x, B was a 9, plus B, which was 9, squared. 4x times another 4x, that is 16x squared, minus sign 2 times 4 is 8, 8 times 9 is 72 with an x, plus 9 squared, that is 81, and you're expanded. Last one says parentheses 6 minus 5x squared squared. This again is also a difference of perfect squares. So A is 6, B is 5x squared. So we write our formula, A squared minus 2AB plus B squared. A is a 6, we're squaring, minus sign 2 times A is 6, B is 5x squared, plus C, which is B, which is 5x squared, and then we're squaring that. So 6 squared, 36, minus signs. 2 times 6 is 12, and 12 times 5 is 60x squared. Plus, now it says 5x squared twice. So 5 squared, there's my 25. 2 x's, and then I'm giving it another 2 x's. You have x to the 4th. And then it's expanded.